What's going on, viewers? Welcome to Shop Talk episode 4. As promised in our previous video, we're going to be doing a video on battery draw testing and multimeter use. If you want to check out that video, click on the link right next to Nick and you can check that out. Let's get right into it. Alright guys, so our specimen, our vehicle for this video is my dad's 1971 Chevelle. So there shouldn't be too much draw in this battery, and this car doesn't have, well, virtually no electronics in it, so there shouldn't be any computers or any security modules creating any draw on the battery. So the tools you're going to need, well, for his car, 12mm socket and a ratchet, and we're going to need a multimeter. I'm using the cheapest, most garbage multimeter I can find. This is like a $10 Mastercraft multimeter, just for the sake of showing you guys that this can be done just in your garage, very basically. This one actually has an amp setting, so it can do current. But first, let's just show you guys how to do, just to check the voltage of the battery. It's just going to give you a basic check on how many volts the battery is putting out right now. Please excuse my dad's Bush League battery hold down here. Yes, it's a block of wood, and yes, this is a MotoMaster Canadian Tire battery. Some people love them. I think they're, well, you know. So to set up the multimeter for volts, you're going to want to put your red, which is your positive lead, into the volt. That is the ohm symbol next to the V, and milliamps area. And then the negative goes in the spot where it says common ground, just always in that spot no matter what. So this doesn't have any fancy automatic range or anything like that, so you actually have to select the range. There's 2 volt settings, sorry, for this multimeter. As you can see, the side that we're going to want to use is the direct current, so that's the volt with the 2 lines above it, and the one that we don't want to use is the alternating current, which is the V with the squiggly line above it. So since this is an automatic range, I'm just going to set this voltmeter to the 20 spot, or sorry, the 200. So basically what the range does is just moves the decimal point. So we're expecting there to be somewhere around 12 volts. So it's going to give us 12 point whatever volts we have. Who knows, it might be less. I'm not too sure, I haven't even checked it yet. So we'll put our multimeter down. Now, first thing you want to do is locate the positive and negative terminals. So it's very clearly marked on this that the positive is right here to the left, and the negative is the line. So positive is the plus, minus is the negative, just to be perfectly clear. You can also check, if you're not 100% sure, you can follow the wires. The positive wire will most likely lead to the starter on this car, and the negative is going to be a ground, usually on the engine or on the chassis of the car, or both. So let's go right in and check the voltage. So we're going to put our positive terminal onto the positive terminal, and our negative probe onto the negative terminal. So there we go, we got 12.5 volts. So there is voltage here. Now don't be misled, you can have 12.3 volts and the battery may not be performing well. So this isn't a state of health test on the battery, this is just letting us know what kind of voltage we're at. So one thing you can do to check draw on a battery is you can see if you have voltage basically across the top of the battery, because the battery can sweat hydrogen deposits on top, like as the battery gets old. This battery won't, it's new, it's good, but when you get into really old batteries and you can see all the green crusty stuff around the terminals and on top, if you just place your negative terminal here just on top of the battery somewhere, or if you see some sweaty spots, you can actually get a reading on your meter, and that's actually draw. That's actually being drawn from the battery. It'll be a very low amount, probably 0.1, 0.2, and that can actually drain your battery over the course of a long period of time. Now, a proper draw test, like to see if something on the vehicle is drawing power in the electrical system is to do a current test. So what you're gonna have to do at that point is switch your meter off, and you're gonna wanna move your your positive lead into this spot, the one where it says 10 amps. So this can read up to 10 amps of current. Anything over that, it's gonna pop the internal fuse inside the meter and render it useless at that point. So you wanna make sure you're not gonna be checking anything more than 10 amps. We shouldn't have anywhere near 10 amps draw. 10 amps draw would probably drain this battery very quick, like within an hour. So in order to properly do this test, the test we just did before, we were testing the battery in parallel, which means the easiest way to describe this to you is we tapped into the circuit. We just kind of probed it, poked it, and tapped into it. Now we're going to be testing it in series, which means we're going to turn the meter into the circuit, basically linking it into the circuit. So this is where our ratchet and our tool comes in handy. We're going to disconnect the negative terminal off the battery, like so. Just loosen it off a little bit. And of course my dad cranked it on. Wiggle it around a little bit. Normally doesn't take this long. There we go. So we have it off. So now the battery's disconnected. So we're gonna link our meter into the circuit. To do so, alligator clips are usually the easiest way and most effective way of doing this, but that's a luxury we don't have right now because we're gonna try and teach you the worst case scenario of a test. Now you're gonna wanna switch your meter into this A setting. That's the amperage or current setting. We're gonna set it on the 20M setting. And that's usually the decimal point moved furthest to this side, I believe, yeah. Furthest to that side. So if we have any draw, it should come up in this setting. If you have draw in the 10 amp setting, something's really gone wrong. So let's check it right in the 20 milliamp setting. So you're gonna put your positive on your negative terminal, your negative wire, and then your negative is gonna go right on the terminal here. So now current's flowing through the meter, and the meter is gonna check and see how much draw there is on this battery. So right now we have nothing. So just to give you an example, if Nick was to go inside the car right now and turn the lights on, we would get a lot of draw. However, that might put us to the point where we blow the meter up because it's going to be too much amperage for the meter to handle. So to show you guys if there was an actual issue with the car, what would happen, we still have everything disconnected, but we've turned the key to the ignition on. So nothing's happening right now because it's disconnected, but since we're completing the circuit with the multimeter, everything will turn on, and this will show us how much draw everything being on is causing. Now, if you had everything off, doors locked, like let's say on like a newer vehicle, you've armed the alarm and the keys out of the car, and you perform this test and you got readings like we're about to show you, you definitely have an issue. Something's drawing the battery, could be an electrical problem, maybe something plugged into the accessory socket is malfunctioning, but this is what it would look like. So since the ignition switch is on, it's going to create quite a bit of current. So we're going to have to put it to the 10 amp setting, which is basically the maximum amount this meter goes to. And basically do exactly what we just did, the same check. So it will arc slightly, so you may see a little spark on this side when I connect it, but the meter will display what's happening. So there we go. 7.1, so 5.6, 5.2, so about 5 amps. And you can hear the radio just turned on in the car because we completed the circuit. So that's the reading. And then as soon as I take this off, it incompletes the circuit. Now, the reason why we were getting a negative reading there, I think, is just because of the direction that we're traveling. If we swap these around, I think that should switch back to a positive. Yeah, see, now it's going to be positive. It was just because the meter basically is like a calculator. So it reads in the direction that current travels. So from negative through to positive, which is over here, right? So there you go. And that's how you perform a battery draw test on pretty much any vehicle. Hey guys, we're in the shop right now. I just want to show you my electrical drawer in my toolbox, because I know we just did that draw test on a very basic multimeter. I want to show you what I think should be the industry standard for a technician for doing electrical diagnostics on a multimeter. So this is my electrical drawer. I'm not going to go through everything in this drawer, but I will show you what's inside this case. This is my multimeter. It's a Fluke 115 True RMS multimeter. Right now I just have the leads coiled up around it. The nice thing about this meter is that it's automatic range selecting. So you set your current or your voltage to direct current. It's also backlit, which is nice, but it's automatic ranging. So if I was to connect these leads to a battery right now, it would put the decimal point or my range in the optimal place for the amount of voltage or resistance or amperage that I'm reading. Also, I have a set of Fluke Leads, which are very high quality leads. They're very bendy, high quality casing. Also, they're 1000 volt Cat 3 rated. So you can use this for testing hybrid components and electric vehicle components. And they also have Alligator Clips, which are also the 1000 volt rated Alligator Clips. Very high quality clips. I don't know if you can see that, but the tip of the clip has a spot where you can grab a wire, not just teeth. So it's not like you're just putting this on terminals. You can actually get a really nice connection on a wire with these Alligator Clips. So very, very good. And that's basically it. A couple other components I would recommend having are some probes. They almost look like hypodermic needles, but they're very good for going in if you're testing inside terminals that are very, very small, they're very good for that. But I just wanted to make sure you guys knew that, we're not just using the cheapest tools out there. We have proper tools, and this is basically what I recommend having in a basic setup. Like if you're doing a lot of hybrid stuff, I would recommend a much better meter than that. There are way better meters than that, but that's what I think is a standard good meter for just doing basic to intermediate electric testing.
Alright guys, that's it for this episode of Shop Talk. We hope you guys enjoyed it, and we hope you guys learned something, because that's ultimately what we want to do with the channel. We want to bring you guys entertaining videos and content that you're going to learn from and actually utilize and use in your everyday work practices.
If you guys have any other information that you guys need or any other topics you want us to cover, please comment down below or send us a message through social media. If there's anything that you think we skipped or didn't cover in this particular topic, please mention it in the comments down below so our viewers can take advantage of that information as well.
And all of the link to our social media will be in the description as well. And if you want to see any upcoming videos, don't forget to subscribe so you guys get updated. We want to keep you guys in the loop. And thanks for watching, guys.
Thanks for watching.